So yesterday, the thing from yesterday's lesson that you need to be sure you understand how to do, okay? Find mean, median, mode, and range of data. Use your calculator, type in a list of data, find the mean and standard deviation by using the one variable stats. Be able to turn on and understand a box plot, and be able to look at a histogram, okay? For the histogram, I don't care if you use Zoom Stat for your homework, okay? There is a histogram question on the quiz. I wouldn't bother to put it in. It gives you a list of data and it's multiple choice. Here's 4 different histograms. Which one fits this data? So you go, okay, it says 0 to 6, and you look at your data and you go, oh, there's 5 pieces of information in that category. You find the one that goes up to 5, and if you're lucky, you're done, right? Okay, you might have to look at the next category if there's 2 choices the same, but I wouldn't bother to put them in and set it all up. All right, the thing we need to discuss today, when we did box plots yesterday, each whisker represented what percent? 1/4 of the data, okay, 25%. So those were quartiles. We were splitting the data into quartiles. Thus the Q1, Q3, remember that? Okay. Today we're going to talk about percentiles briefly. Percentiles divide a distribution into 100 equal groups and are symbolized like this. We're not going to use that notation. We're just going to talk about percentiles real quick. A percentile graph uses the same values as a cumulative relative frequency graph. Wow, do we remember anything about that? We talked about that. Okay. We're going to do that today. I'll show you in just a second. This is an example that says they took 200 students' GPAs and put them in here. 200 students who were between a 2 and a 4 GPA. Okay? They broke it down into 1/4 of a points. All right, before we go any further, I just want to stress this, that percentages are not the same as percentiles. If you get 85 out of 100 points on a test, you got an 85%. A percentile is comparing you to the other people who took the test, okay? You might have scored at the 90th percentile, meaning 90% of students did worse than you. Does that make sense now? Okay. This is the same data from the first chart. Here's the class bounds, the GPA from 2 to 4, and the number of people in each category. A cumulative frequency means you want to say there were 10 people in this category, but when you get to here, you want to say there are actually 38 people who scored below a 2.5. Okay? You're accumulating or adding up as you go down. So there was 38 people. Then you get to this one, say below a 2.75, there are all of these, or 68 people. What did they add to get to 100? They added these 32 into the next group, okay? Now, how many people were there in this survey? Do you remember? 200. So then they divided each of these cumulative frequencies by 200. So by the time we've hit 2.25, we've only accumulated 5% of the people there. All right, so at 2 there was 0% because we didn't have a percentile yet. By 2.25 we were at 5%. Then by 2.5 we were at 19%. By 2.75 we're up to 34% and so on, okay? 97%, we added these 6 people in and we hit 100% of the people. We're going to do the same thing. Oh, then they use this, they use this graph for you scored, your GPA is a 3.4. So you look at this and you go, okay, I'm just a little bit below this 3.5 line, which puts me at roughly 78 or 79% percentile, okay? So if you have that little graph, you can use it to estimate something. This is a real quick example of test scores, okay? So we had 3 people who scored between a 55 and a 60.5 a 55.5 and a 60.5. So there was 3 people in that category. How are we going to figure out the percentile for that? The cumulative percent. Yeah, we have to know how many people took this test. Actually, let's just keep going down this column and we'll figure it out. Because what do we do next? We add these together and get, and then we add all these together and we get, we're going to add 12 onto that, which would be 23. Then we're going to add 5 onto that, which would be 28. And then add 9 onto that, and we'll have 37. So therefore, to find the percent, we're going to divide each one by. So 3 out of 37. Anybody have a percent for me? Okay. We're supposed to graph this thing over here, and it's not going to be very accurate, so I mustn't go with 8%. 11 out of 37. 30% roughly. We're not going to be able to be very accurate when we graph, so I'm not going to be too worried about it. 23 out of 37. Anybody have that one? 28 out of 37. And 37 out of 37 would be 100, right? Okay. We're going to use this as our cutoff when we graph it, okay? So, and I don't have a very good way to make this fit on the screen unless I shrink it all down, and then my numbers won't fit in the chart anymore. The first one went to what, guys? 50.5 or 55.5? 55, I guess scroll back up. 60.5, okay. 60.5, we hit 88%. All right, I'm sorry, I'm struggling here. 60.5, we hit 8%. Started at 55, so if we want to put that covers that percent, doesn't really matter. All right, the next one is 60.5, and we were up to what? 65.5, thank you, and we're up to 30, okay. And the next one is up to 70.5 and 62. Do I have that right? And the next one is 75.5 and 76%. And then by the time we're at 80.5, we've hit all 100%. Oh my goodness. None of my lines are straight. It's just a hot mess. Okay. We have one more question. It says 62. A 62 on this test would put me where? If I scored a 62, oh my. Can't draw that straight either. Okay, if I scored a 62 score, what do you want to put for your percentile? What's better on yours? 15, 16, 17, somewhere in there? I'm going to say 16%. I did a crummy job of drawing the whole thing, so I don't know if you used a ruler for be better. All right. There's one of these on the homework, and I don't think there's one all on the quiz that's a cumulative percentile graph that you have to try to graph anyway, okay? That brings us to the end of this assignment, which was 11.1. You have a couple questions where you have to put in graph, look at the histogram, decide if it's skewed left, skewed right, uniform or symmetric. What's the difference between those two? Uniform would be they're all exactly the same. Symmetric would be if I drew a line through the middle, looks the same on both sides, right? All right. You also have to do a box and whisker plot. You have to decide, again, skewedness. You have to find the mean and standard deviation and all that kind of stuff. 11 through 14 are simply matching. You don't have to do a bunch of work for those. It says match each histogram to the box plot. Can you do that? Number 13 is skewed which way? Skewed left. What does that mean in terms of the box plot? The left whisker is long. So number 13 is probably A, right? Okay. That's it. We are now moving on to worksheet 11 and the normal distribution. Everybody ready? Worksheet 11. Okay. The normal distribution is a I don't want to read that part. Continuous probability distribution is called the normal distribution, the most widely used one, okay? These are the characteristics. The data turns out to be bell-shaped. Part of the reason that that is true is because the mean, median, and mode are all in the middle. The mode is always the highest part, right? Mean and median are the middle. If it's perfectly symmetric, then the mean and median will always be at the same place. If it's the peak, it's also the mode. The curve is continuous. It approaches but never actually touches the x-axis down here, okay? The total area under the curve is 100%. If you were to take a set of data, like they took 100 runners and their time for the 400-meter run, and they got this data. Then they did it with 1,000 and then 10,000 times. And the more times there are in it, the more normalized it will be, okay? Just think about the PARCC test. Remember we said there's really no scores yet because the test hasn't been normed? In other words, they haven't given that PARCC test enough times. When they've given it enough times, then it will approach this, and then they can say the mean is this, and you are exactly this percentile above what the average score is, and that kind of thing. Yes. Number of the yes, the sample size. Sample size. Good question. All right. I included this because I wanted to show you that your calculator. We're going to switch over to doing this. We're going to talk about this empirical rule, which is a rule of thumb for finding normal distribution information, okay? But the calculator actually will find it a little more accurately for us, and then by the end of the lesson today, we're going to talk about how to do this all on the calculator. This is what your calculator is programmed to find the equation of the normal curve, and then it does the area under the normal curve. This is from the old book. Okay. Our book doesn't even give us the equation. It's so disgusting looking, okay? I just wanted to show you how fun it was, and of course, Chandler wrote it all down. He was going to go mess with it, but it's just nasty. It has a lot of variables. Do you notice this? Okay, y equals, and you leave the x when you graph it. But you have to put in the standard deviation. Anybody know this Greek letter? This is mu, yes. And the standard deviation is? Yeah. So we're going to do, but it also has a pi, which actually isn't a variable, it's a letter. And it has an e, which also isn't a variable, it's a number, I should have said, not a letter, okay? So pi and e, natural, log, e, that kind, and a pi. Crazy. Anyway, we're moving on here. We already talked about this. When you have a standard normal distribution that looks like this, oh, I can't draw it today. What they're going to, or a straight line. What they're going to do is put a 1 here. They're going to put say the mean is 0 and the standard deviation is 1. Either way, okay? So we're going to go with this empirical rule first, and then we're going to learn to do it on the calculator. This is known as the 68, 95, 99.7. Do some of you remember doing this before? Yeah. Okay. So one standard deviation either way will contain 68% of the area under the curve, or 68% of the data. If you go out 2 standard deviations, it's 95%. If you go out 3, it's 99.7, which is almost 100%. Even in AP stats and stuff, I think they use 4 as 100%. Okay, 4 standard deviations. In theory, it doesn't ever actually hit 100% because it doesn't ever touch the x-axis. All right. We're going to talk about this in terms of a couple specific examples. It says the height of 880 students are normally distributed with a mean of 67 and a standard deviation of 2.5. So the 67 goes in the middle, then we start adding and subtracting 2.5. So they added 2.5, got 69.5, added another 2.5, got to 72, add another 2.5, and we'd be at 74.5. If we subtracted 2.5, we'd be at 64.5, if I'm doing this right, 62, and 59.5, if I did that right, okay? How many students are more than 72 inches tall? Remember how it went? This was what percent? 68. If you go out 2, you're at 95. Now, if you're at 95 within 2, but you want everybody who's above on this end, 95 from 100 is 5%. So there's 2.5 up here and 2.5 down here, right? And we want everybody at this spot and down or up? More. Okay, I'm going the wrong way. So all we want is this little piece up here. So it's 2.5%. It didn't ask for percent, though. It says how many actual students of the 880. So then you would take that 2.5% times 880 and get 22 students. This one just asked for the percent. Same question. What percent fall between 59.5 and 69.5? Remember back here when I wrote all these, let me see if I can erase some of this. Or not. Let's go with this. They want to know on this one, what percent of the students are between 59.5 and 69.5? If we go back here, 59.5 to 69.5 is here. All right. The third standard deviation out was what percent? 99.7. Okay. So what does that leave? 0.3% or 0.15 on either end. All right. We want everybody, what's this little piece right here, guys? 34. And basically this is half, right? It's 99.7 divided by 2. What's 99.7 divided by 2? Okay, that takes us to here, and then this is 34. So if we add that together, we get 83.85%, or roughly 84%, which is what they got. Okay? If you look at the little chart on your paper here, it says 2.35, right? It's that little dip at the end. So they added all that up. Got 83.85, or about 84%. And that's all they wanted, was the percentage on this one. All right, I'd like us to do a couple using this rule, and then we'll learn how to use the calculator. Sketch one, and mine is not going to be good, I promise. And then we need to put in the mean and the standard deviations. If we go 4, okay, the first one, they should be the same distance apart. And mine aren't because I ran out of room. Okay, the mean here is 65, and what are they counting by? What are the standard deviations? 5. So this would be 70, 75, and 80. Going this way, we'd have 60, 55, and 50. So what percent should fall between 50 and 70 is what they're asking? We just did this question. Because this was 34%, right? And this is roughly half, but it was actually half of 99.7. Will give us this distance over here, added to 34. So do you remember what it came out? 83.85, or roughly 84%, which would just be the bottom half plus this 34% is fine. So the average monthly temperature for this city falls between 50 and 70, 84% of the time. Next question has trees. 200 trees were surveyed. They asked them their height. All right, they measured the trees and got a mean of 120 and a standard deviation of 16. So 136 would be the next standard deviation up, right? How many are more than that, though? This is 50% down on this half, right, guys? This is 34. So how many are more than that? Out of all the trees, if you took off the lower 50 and the next 34, you'd be at 16% left to be above this. So 200 times 16% is absolutely 32 trees. Are approximately 32 trees are above 136 inches tall. Okay, what percent of the trees fell between 88 and 104? Again, they want us to continue to use this rule, the empirical rule. If we take 120 minus the standard deviation of 16, we're at 104. If we subtract 16 again, we're at what? 88. So we want this little piece in here. Yeah, it's 13.5 on the chart, right? If you look at the actual picture here. Right in here. If I talk you through this, just so we're sure you know where they got that. This is 95 out 2 standard deviations. So if we took 95 divided by 2, we would have what? 47.5 is from here to here. And then if we subtract the 34 that's in here, that leaves us with 13.5. Okay? Do we have to do anything else with that? Just ask percent on that one. All right. The numbers we were given in those 2 examples fell right on a standard deviation line. Did you notice that? Okay. I didn't ask how many trees were between 85 and 106.8, right? I asked numbers that were right on the standard deviation lines. When you are not given numbers right on the standard deviation lines, you use what's called a z-score. A z-score is really helpful. Is everybody listening? If you took the SAT test and the ACT test, would you automatically know which one you did better on? But the scores aren't even close to the same, right? One is out of 36 points and one is out of 1,800, 1,600, 1,600, okay? So just because I got a 1,200 on this and a 24 on this, that tells me nothing, okay? But if you knew how many standard deviations you were above the mean or below the mean, could you then compare the two? Okay? A percentile would do the same thing, but we're going to go with, if you wanted to know, throw me an ACT score. Okay, I'm going to say the mean is 22, which is probably high. It's 18.
Yes. 18 is average.
Okay. And I'm going to say the standard deviation is 4. Okay. So how did you do?
You did really good.
Isn't that 11? Did I? 2 point. So you scored almost, at a 29, you scored, according to made-up Hofbauer data, you scored almost, you scored about between 2 and 3 standard deviations above, almost 3 standard deviations above, okay? But if you did the same thing with your SAT score, could you then see which one was better in comparison to how many standard deviations you were above the norm?
Standard deviation is 6.
You looked it up online for me? Thank you. So 11 divided by 6 is, if we change this to 6, we'd have not quite 2, 1 point. So we'd have your 1.8 standard deviations above the mean, okay? All right. I'm pretty sure the mean is not exactly 18 probably, but you need to know this idea that you take your score minus the mean divided by the standard deviation. That gives you the z-score. It is my intention to make a reference sheet for this test, but I haven't done it yet, and it does ask you to find a z-score. So, do these two really fast because this is the easiest algebra I'm going to ask you ever in pre-calc. It says find the z-score. If your score was 65, the mean was 50, and it's a 10. Standard deviation is 10, sorry. What do we get? Okay. What if your z is negative 0.4, and the mean was 40, and the standard deviation was 5? How do you work backwards and figure out what your score was? 5 times negative 0.4 is... plus 40 is... So on a test that had a mean of 40, you scored a 38. Now, notice the z was negative, okay? We didn't talk a lot about that. If you look at this, this shows exactly the same numbers we just used, right? 34, 13.5, okay? But instead of saying this is mu plus 1 standard deviation, it just says it's a 1. This is a 2, 3 z-score. It's the same thing, it's number of standard deviations, but they're negative going to the left, okay? They're below the standard, the mean, sorry. Used to look up the z-score on a table. So if you had a z-score of 1.42, you had exactly 0.992% of the data below that or whatever, okay? Our calculator does that. We're going to go ahead and do an example using the z-score. I'm going to do this one that's on your paper. Then I'm going to show you how you don't even have to use a z-score at all. All right. On his last 20 airline trips, an employee had an average layover time of 82 minutes with a standard deviation of 7.5. Find the number of layovers that were less than 75 minutes long. Gentlemen. So we have a mu or mean of 82, a standard deviation of 7.5, and we want to find less than what? Less than 75. So we need a z-score because if we were to draw this and we did 82 and we subtracted 7.5, what's 82 minus 7.5, guys? 74.5, okay? But he wants to know less than 75. So he's not quite at that one. He's here, and he wants to know below that. Okay, so we can't use, it's not exactly on a standard deviation line. All right, what we're going to do is find the z-score. So we're going to take his 75-minute question here and subtract 82 and divide by 7.5. How many standard deviations away is he? Negative 0.93? Okay. Do you remember what I said that they use for standard number of standard deviations out that covers 100% of the data? Well, we said 3 was 99.7, right? They used 4 to cover everything. They say 4 is beyond what you need. All right. So we're going to use our lowest value of negative 4 up to, we want this value of negative 0.93. We want to know how much area under the curve is in between there. It is actually possible, don't try to do this, okay? It is actually possible to have the calculator draw the curve, and I'm pretty sure I won't even be able to get this to work because you have to have a very specific window. That's why I'm telling you not to do this, because we're not going to bother. But if I go here to shade normal from negative 4 to negative 0.93, I'm going to set my window from negative 4 to 4. And I'm going to set my y from 0 to, I think only I need 0.5 or something. All right, then I'm going to go back here. I got to clear the graph. Didn't I just tell it to turn those all off? What's it doing? Hates me. Turn all my plots off, which is 4. Done. Okay. One more time. Negative 4 to negative 0.93. We'll see if it works, otherwise I'm giving up. Oh, I have to just hit enter, I think. Okay, last chance. Otherwise, this is going to be the longest 5 minutes of nothing on my video. Gotta go down to draw. That's what I gotta do. Okay. So there's the shaded area that's to the left of that, and it tells you right there. Can someone read that number? Somebody up in front? It says the area is 0.176. Okay? We're not going to have it draw this because, as you just noticed, it took me forever, and it's a big pain in the neck. And now to undo this and do a new one, you have to go to this spot and tell it to clear the drawing, and then you have to go back and redo it, and it's just a big pain in the neck. There's another way to do it. It says to use this norm CDF. So I want everybody to do this. It's the same spot we were yesterday. We're going to go to second vars key, which is the distribution menu. We're doing normal distribution. We're going to choose the second one, CDF. That's the only one we're going to use. Okay, normal CDF. Then it asks for the lower bound and upper bound. We use negative 4 and negative 0.93. And if we're using z-scores, this is 0 and 1. The mean and the standard deviation are 0 and 1. If you have an older calculator, all you need to do is normal CDF, negative 4, comma, negative 0.93, and you can hit enter. It will default to 0 and 1. Everybody get 17.6% again? Okay. Somebody helping him? Okay. Make sure the mean positive 0.93 won't give you that. Do you have negative and negative? All right. This question then said out of the 20 flights, how many were that? So they took that 0.176 times 20 and got 3 point something and rounded up to 4 flights were about, 4 of the flights had a layover of less than 75 minutes, okay? Let's try a question. We're going to use z-score again this time, and then I'll show you how to not. At a restaurant, the average time between when an order is placed and when the entree is served is 12.5 minutes with a standard deviation of 1.2. Okay, so the average is 12.5, and you really don't need to draw this if you don't want to. And the standard deviation is 1.2. If we go up 1.2 above this, we're at 13.7. We go up another 1.2, we're at 14.9. They want to know how many people got their meal within 14 minutes. Everybody good? Now, is 14 right on a standard deviation? So we're going to find the z-score. How do we find the z-score for 14? Okay. So 14, how many standard deviations is it above that? So 14 minus 12.5 divided by 1.2 is what? 1.25 standard deviations. Now, how do we say from the bottom up to 1.25 above? What are we going to use for the lowest? -4. And what are we going to use for the top? 1.25. We're going to leave this 0 and 1. Because all of the data goes between, okay, they say -3 and 3, but you can go out as far as -4 and 4, okay? You could use -3 and you'd get almost exactly the same answer. Someone else get that? Now, we're going to get a slightly different answer the way I'm going to show you. We're not going to use z-scores. We're going to be super lazy. We're going to go to the same spot, and without calculating anything, we're going to put in the numbers from the question. Okay. I'm just going to use a little logic here. What's the least time you could possibly get your meal? Okay, so I'm going to put my lower bound to 0. What is my upper bound? I want to know how many people get it by 14 minutes. The mean was 12.5, and the standard deviation was 1.2. Now, you're going to get a slightly different answer, but is it still about... Yeah, after it's off back here a little bit. Yeah, it's not off by much. Okay, can we answer the question, guys? How many out of the 100 people got their meals? About 89 people. Okay, moving on to the next question. We can do this one either way. You guys pick. I don't care. Ms. Kwan, a full professor at community college, earns a salary of, and you don't need to draw. I'm just trying to keep this in mind. The mean is $52,000 of everybody. She earns $48,600. She wants to know, is anybody making less than me? Okay. So she wants to know, of the 45 full professors, how many earn less than she does? This is not necessarily on a standard deviation line, though, because the standard deviation is 3,600. If you take 52,000 and you start subtracting 3,600, She's, the first standard deviation is 48,400, so she's just above that. Okay, which way do you want to do it? You want to find the z-score or not? If you don't find the normal, what are you going to use for your lower bound? You want to use $0? It'll work, okay? You could actually find what 4 standard deviations below that was, but does that sound like fun? Okay, you could round, honestly guys, you could round this to 55,000 and round this to 5,000 and subtract it 4 times and you'd hit a lower bound. It doesn't matter. You can use 0 every time for the lower, okay? Now, she wants everybody up to 48,600, where the mean is 52,000 and the standard deviation is, okay, what percent do you get? 17.25% times 45 is roughly 8 professors earn less than her. Okay. So if she's like the 8th person, maybe only 7 people are below her, but somewhere in there. Okay? All right, last question. Nope, there's 2 more, but the last one's super easy. So if Faisal leaves early, it's not a big deal. Let's do this one. How many days in October?
31.
31 days. Okay. The average water temperature of a pond was 53.2 with a standard deviation of 2.3. How many days was temperature greater than? Greater than 50. So what are we going to do this time? Our lower is 50. Our upper needs to be at least 4 standard deviations above the mean. Would 150 work? 99999 work? Okay. If you rounded this to 55 and 2.5 and you went up 4 standard deviations, you'd be at 65. So anything above that would be fine. 150 is fine. You'll get the same answer, I promise. The mean is 53.2, is that right? And the standard deviation is 2.3.
91.8%.
Okay. I got 0.9179. If I redo it with 150 to make Faisal happy, that's okay. I get the same decimal. The first place it's, actually I get exactly the same decimal. Doesn't matter. On my calculator. All right. So did we answer the question though? About 28 days, right? All right. One more time. The average age of swimmers. So this is a master's swim team. We got a bunch of old fogies making a swim team. Okay, like me. It says the mean age is 56. The standard deviation is 4. What is the chance we pick somebody at random and we get them to have an age between 53 and 59? This one is just 53, 59, what? 56, Brenton, this is the easiest thing ever, and you're sleeping. Make sure you know how to do this for the test, because this should be an automatic. What words are you going to look for that tell you to do this, guys? What is the title of this lesson? Normally distributed, yes. The age of the swimmers was normally distributed. This is what's telling us to use this. What was the chance on that one, guys? About 55%? Did anybody get close? What are we going to use for less than 53, though? 0 will work. Somebody already get that one? $22.66 or 23%. Okay. By the way, I do fall on the less than 53. Barely. All right, guys. You can start working on this assignment if you happen to have finished yesterday's. I'm not holding my breath on that. Okay, page 681. Tomorrow we will finish this lesson and talk about finding the middle